Hello everyone, welcome back to Quadratics. So today's video will be focusing on this year's trial paper for Kedah, and we are going to paper 1. Alright, and the difficulty of this paper, I would say, is 3.5 over 5, because I think that some of the questions quite straightforward, but some of the questions might need some time to think to able to solve those questions, especially questions in section B. Okay, the last 3 questions. Alright, so without wasting time, let's discuss this paper together. Question 1 is a typical logarithm question, and we are going to use the 3 main step method, which helps us to solve any kind of logarithm question. Alright, so the first step is to change the base. So meaning the values here, so these are the bases, we are going to change them all to become the same value. But as you can see here, all of them is the same already. Okay, so we can skip the first step and go to the second one, which is to manipulate. So manipulate meaning we are going to manipulate or change the logarithm values that we have here so we can simplify them. So for example, as you can see, all of them have log, so why not we move all of them to the left side and then we simplify them so that we can form one simple log. Right? So as you can see in the formulas here, if it's plus, we are going to multiply. If it's minus, we are going to divide. Right? So as you can see here, plus or meaning positive values, we have 1 here and we have 1 here. So all positive values put at the numerator. So x minus 2 and 3x plus 4. And then the values which are negative, 2 and x squared, we are going to put at the bottom. Alright, so this is for step 2. So once we reach here, we cannot simplify anymore. So to further simplify, we are going to use the third step, which is to change the form. So currently, this is the logarithm form. So what we need to do now is to change to the index form. So log form is usually log base ay equals to x, and for changing to the index form, we are going to move this a to the opposite side. So here is just y equals to a power of x. Right? We are just going to move the base to the opposite side. So same thing here as well. For the 3, we are going to move to the opposite side. So here will be 3 to the power of 0. Right? So the things inside the bracket, we can just remain, but here I just cross multiply these 2 brackets lah. Alright, so starting from here is just simplification. Alright, so 3 to the power of 0 will be 1, and then I move this 2x squared to the opposite side. And then I move this value to the left side, then we can get a quadratic equation, and we can use the calculator, factorize them into 2 answers that we want, right? Which is 4n minus 2. But here, most of the students will forget, which is to check whether these 2 values, can it be substituted back into the logarithm values here. Alright, so logarithm values, as you know, the value of x here must be greater than or equal to 0. Meaning it cannot be a negative value. Right? For example, this x minus 2. So this one we need to reject. Okay. Reason is because if we substitute negative 2 inside this logarithm value, it will be log base 3 minus 4. If you type this into calculator, you will get an error. Alright? So we need to accept 4 as our answer, because if we substitute 4 inside these 2 logarithm values, both of them are positive. Question 2, coming from quadratic functions, and in part A, we are going to use the method of line number to find the range of x using this inequality. Right? So again, range meaning in our answers there will be inequalities. Okay? So to start off, we can move everything from the right side to the left first, because we can factorize this quadratic equation using the calculator and find the 2x values. So the 2x values would be 1 over 2 and negative 3. Okay, alright, so now how do we use this method of line number? Right, so what we can do is we are going to put the 2x values onto this number line. So meaning split them into 3 parts. Okay, so this means for the first part, we are going to focus on values which is less than this number. Here will be the values which is between these two numbers, and here would be the values which is larger than this number. Okay, then what we are going to do is select one value from each of the parts and substitute inside here. Then we are going to check whether it's positive or negative only. And if you look at here, it's greater than or equal to 0. So means we are going to find the parts which are positive. So if we select they are positive, that means the part would be our answer. Right? So for example, for the first part, let me choose -4. Okay, so if I substitute x with -4 here, you will calculate that this is -9, right? Or meaning a negative value. Then here, if I substitute -4, it will be -1, which is also a negative value. So negative, negative, positive. So this is one of the parts which will be our answer because we are searching for positive parts. Alright, so for this part, I am going to choose 0 as our answer because it's 0 as our value because it's easier. Right, so 0 substitute inside here, it will be -1, which is negative. Then 0 substitute inside here, it will be positive. Okay, so negative, positive, negative. So this wouldn't be our answer anymore. Alright, and for this one, let me choose 1 as our value. So if I substitute here, it would be a positive value. If I substitute here, would be also a positive value. Positive, positive, positive. So this means these two parts will be our answer. So our final answer will be x is less than or equal to -3 or x is greater than or equal to 1/2. For part B, we are going to use the completing the square method to find the maximum or minimum point from this quadratic equation. Right. So let's recall back, completing the square, we have 3 main steps. The first step is to factorize the value of x squared from values that have x. Okay, so for example, for the x squared value, we are going to just take out the 2. But for this value, because it has an x, we also need to take out 2 from -12. Right? So here what we need to do is -12 divided by 2 to get -6. Right? And for the value here, we can just ignore, remain it as it is. So this is the first step. The second step is to divide and square the value of x, which is -6. So what we need to do is we need to add a value which is -6, divide by 2, and then square. Okay, and because we added this value, we need to have a counter effect, right? When we add something, we need to minus something. So here we are going to put the exact value, it's just that we are going to put negative here. Okay, and then we remain the 10 as it is, and this is the second step. And the third step here is to combine. So meaning we are going to combine the first 3 values that has square. So for example, x here and -6 divided by 2, which is -3. Okay, and for the rest of the things here is just normal simplifying. Okay, so this if you simplify, you'll get -9 and the +10 will remain. And here we just multiply the 2 back into the values inside the bracket lah. Okay, so once we simplify, then we can find the final form, and this final form is called the vertex form. Alright, so now we have this form, we can find whether it is maximum or minimum. So we can look at the value of a, which determines the shape of the graph. So recall back, if a is greater than 0 is a smiley face, a less than 0 is a sad face. So now it's a positive value, so meaning it's a smiley face, and this means smiley face we have a minimum point here, so we are going to find a minimum point from this equation. Okay, and also to find the coordinates of the minimum point, we can just use the value of h and k, which is 3 and negative 8. Okay, so our minimum point is 3, negative 8. And here just a reminder, when we extract the values from this bracket, make sure to change the sign. So as you can see here, negative, we change it to positive. Okay, so if it's positive, then this means that we need to change it to negative lah. So we need to change to the opposite sign. So this is I would say a common mistake for students, which is they forgot to change the sign. Okay, so please make sure you do this here. And for the next part of the question, it says to find the axis of symmetry. So if you look at here, h helps us to find the axis of symmetry. So the value of h here is 3. Okay, so our axis of symmetry, our answer should be x equals to 3, yeah? It's not 3 only. Okay, because axis of symmetry is the middle line of the curve. Axis of symmetry is a line. So we need to put the x equal in front to make sure that it is a line. 3 is just a value, which is not a line. Okay, so please make sure here, write x equals to 3, not 3 only. Question 3 focuses on quadratic geometry, and it is describing the location of these 3 people's houses. Right? So why not we plot a diagram to understand this question better? Okay, so here in this sentence, they are using Siva's house as the reference. So why not we plot Siva's house here first? Okay, and it says that the north of Siva's house, which is in this direction, is Raihan's house, and the east of Siva's house is in this direction, is Tan's house. Okay, so from this diagram here, we need to show this equation. Okay, so this diagram tells us one thing, which is these two lines are actually perpendicular to each other. So we can use the perpendicular equation to help us. So means that we are going to multiply the two gradients of these two lines and equal to -1 to prove this equation. Okay, so here very simple, to find the gradients we can just use the gradient formula lah. So here y1 minus y2 and x1 minus x2 for the first line, and for the second line is y1 minus y2, x1 minus x2. Okay, and then we just cross multiply the numerators and the denominators, and for the denominator we are going to move to the right side and then move this part to the left side, and we are going to change values which are negative to positive or positive to negative. Okay, and then we have proved the equation. Question 4 focuses on trigo functions, and I would discuss part B1 as the last question we are going to discuss, because here for the other 4 questions here is quite similar. We are just finding the information from this diagram to solve the questions. Okay, so for part A1, we are going to find the value of y-intercept, which is here, so the answer would be 0. Okay, for part 2, we are going to find the equations. Okay, equations meaning we have more than one answer, and we need to find the equation of asymptotes, which is the two lines here. Okay, so asymptotes are the lines where the graph cannot intercept. Okay, so how do we find the equation of these two lines? So very simple, just find the midpoints of the given x values here. Right? So for example, the middle of negative 2 pi and negative pi is negative 3 over 2 pi, and negative pi and 0 is negative pi over 2. Okay, so the equations we can write it in this way lah. So x equals to negative 3 over 2 pi and x equals to negative 1 over 2 pi. And make sure you split it to write out the answers. Don't write it in this way, because this means that the x value here are values, not a line. For lines, we need to make sure to put x equal in front, which is similar to axis of symmetry. Okay? And for part B2, we are finding the domain of x, so we can look at all the values of x in this diagram. Right? So the x values actually start from here, which is negative 2 pi, until here, where x equals to 0. So our domain will be negative 2 pi to 0. And for part 3, the range of y, so we're going to look at all the values of y, which is here. Okay, so the lowest value of y we are unable to find because this graph can go even below, right? So here, there's no lower limit. It's like negative infinity here. But we have an upper limit for y, which is this x-axis line, which is y equals to 0. Okay, so to find the range, what we can do is, since we don't have the lower limit here, we can just write out the upper limit only, which is y is lesser than or equal to 0. Okay, so let's go back to part B1 and let's write out the equation of this graph. Right, so let's identify what type of graph is this. Okay, is it a sine graph, is it a cosine graph, or is it a tangent graph? So in part A2, it says that it has asymptotes. So the only graph that has asymptotes is tan. Right? So we are going to focus on the tan graph. So now what we need to do is to identify the values of A, B, and C. But before that, we need to know what does A, B, and C represent first, right? Okay, so before I explain, I would explain it in this sequence, B, A, C. Okay, so for B, is actually representing the number of cycles within 360 degrees. Okay, so let's draw out a very simple tan graph first. So this is the tan graph within 360 degrees. Okay, this is one cycle. So how do we compare with the diagram here? Because the shape is totally different, right? So what we can do is let us split them into parts. Okay, using the asymptotes. So here we have 1, 2, 3 parts. We have 2 asymptotes. Here, same thing as well. We have 1, 2, 3 parts and we have 2 asymptotes. And if you look at the x values, it starts from negative 2 pi. Negative 2 pi is actually negative 360 degrees. So everything happens here is within 360 degrees, same as our graph. And these two graphs have the same parts, which is 3, and also have the same asymptotes, which is 2. Okay, so this means this graph only has one cycle, which means B is 1. Okay, so now let's go to how can we transform our graph to become something like this. Because as you can see, everything is below the x-axis. For our original graph, some parts are above, some parts are below. Okay, so how do we do this is using these two things. The first thing is modulus. So modulus helps us to move the graph which is at the below of x-axis to be above the x-axis. Okay, below to above. Another thing is using the value of A. Okay, so A helps us to find the minimum or maximum value, but if we change the value of A, let's say from positive to negative, okay, it will flip the entire graph. So means the parts which is above the x-axis will go below the x-axis. the parts which are below the x-axis would be above the x-axis if we change a from positive to negative. Okay, so how do we use these two things to change the graph into this way? Alright, I think the first question is, how can we move everything to be just one side? So meaning everything either above or everything either below. So we can use modulus to help us, right? Because it only moves some part of the graph to the top, those which are below the x-axis to above. Okay, so why not we change our current graph here? So using modulus, the graph would be something like this, right? If we focus on the purple part, everything is above the x-axis already. So we have successfully moved everything to one side, which is all above the x-axis. So now, to move it to below, which is something like this, we can use the value of a, changing it from positive to negative. Because things above the x-axis will go below. So the graph would be something like this already. Right? The blue part is actually the same thing as the one here. Okay? So this means the value of a here would be negative 1. So we are going to use the modulus first, then only the value of a. Right? So this means for the value of a here, we cannot be included in the modulus. The modulus must only include tan, bx only, not the a. Because again, we are using modulus first, then only the value of a to change the graph. And C is actually the axis of symmetry, which is the original graph's middle line. Right? The middle line of the original graph. So for example here, the middle line is the x-axis. As you can see, the most crucial parts of the graph, right, all still intersect the x-axis, which is actually similar to here. All the most crucial x values are all touching the x-axis. So this means the axis of symmetry didn't change, which is still the x-axis, which is 0. Okay, so the value of c here will remain as the same thing, which is 0. Right? So our answer would be y equals to negative modulus tan x. Question 5 focuses on circular measure, and in this paragraph there are a lot of important information. So let me summarize and explain in this diagram. Okay, so for the circle here, the radius is 30 meters, and it says that the shaded region here, they would be planting flowers, and this minor sector OAC, they are planning to use it as a photo booth, and it has tiles. Alright, and also it gives us the ratio for the line OAP, and OA is 3 parts, AP is 1 part. So this means that since OA is 30 meters and it has 3 parts, so this means 1 part is 10 meters. Right? So here for the part AP would be 10 meters. Okay, so here in part A, it gives us the perimeter of the tiles area, which is this beige colored area here. We need to find the minor angle of sector OAC, which means it is here. Okay, so let us put as theta first. Alright, so how do we relate perimeter of tiles area with the minor angle of sector OAC? Seems like these two things are completely different. So what we can do is identify the lines of the tiles area first. Okay, there are 3 lines. So the first 2 is actually the radius of the circle OA and OC, and the third line is the arc AC. So recall back the formulas in this chapter. If you want to find the arc length, it would be r, which is the radius of the circle, multiplied with the theta. Theta is the angle that we are trying to find here. Okay, so there is a relationship between the minor angle and the perimeter. So to find this angle, what we can do is form an equation according to the information here. Okay, which is this one, and let's identify the lines of the tiles area, okay, which we have already mentioned. So it's line OC, OA, and the arc AC. Okay, and we know that OC and OA is the radius of the circle, so both of them will be 30, and arc AC here will be R, which is 30 multiplied with the theta. Okay, so now you can see all of the things are numbers already except the theta that we are trying to find. So we can just rearrange this equation to find the value of theta, which is 4/3 radians. And for part B, we need to find the area for the flowers area, which is the shaded region here. So what we can do is use this technique, which is big shape minus the small shape. Right? So big shape meaning we find a recognizable shape that includes the shaded region. So for example here, the sector OPR. Okay? As you can see, it includes the shaded region. And why I choose sector is because we have a formula that helps us to find the area of sectors. Okay? So later on when we calculate, it will be easier. Alright? And for the small shape, I would say would be the shapes that is included in our big shape but we don't want it. For example, the photo booth area or the sector OAC. Okay, so this is our small shape. Alright, so to find the area of the shaded region or the flowers area would be area of sector OPR, the big sector here, minus the area of the small sector OAC. So to find the area of OPR, so it's 1/2 multiplied with the radius of the sector, which is actually 30 plus 10, so it's 40 here, and we need to square it, then we need to multiply the theta, which is the answer that we got in part A, which is 4/3. So it's similar to area OAC as well, so 1/2 multiplied with the radius of the smaller sector, which is 30, and we square it and we multiply with the theta, which is 4/3, then I minus these two values together to find the answer. Question 6 focuses on vectors. So here we have a diagram, and here we have a situation where Ali needs to go from his house to the school, okay, which is point A to point C, but all the roads connecting to the post office is closed, okay, because of flood. So all of these three lines cannot be used. So the only way Ali can go to school is passing through the bank. Right? So A to B, B to C. Okay? So in part 1, it says that using the laws of triangle, express the movement in column vector. Okay, so let me explain what does these two mean. Alright, so for laws of triangle, which means that we can use two ways to find the similar vector. Okay, so let's say we are finding the vector to go from A to C. Okay, so the first way can be direct to go from A to C, right? Which is this vector. So the first vector would be AC. Okay, the second way would be I can pass through this point, point B. So my way will be going from A to B and then B to C. Okay, so this is the second way, from A to B and then B to C. Alright, so since these two ways we are finding the same vector, which is from A to C, so this means these two are the same, right? Which also means I can form an equation from here. So AC will be equal to AB plus BC. Okay, so this is the law of triangles. So going back to our situation here, Ali is going to school. So the vector that we are trying to find here is AC. Okay, but we don't have a direct route to go from A to C, right? So we can only pass through B. So we can use another way to find the vector. So A going to B, B going to C. Okay, so our vector here would be AB plus BC. But here we have an issue because we are finding vectors, but the diagram only gives us coordinates, right? So how do we change coordinates to vectors? Okay, so in the question here it says that we need to write it in the column vector way. So column vector means that, okay, usually when we write the vectors, right, we always write it in this way, correct? So column vector is just writing the values of vector I and j, which is x and y, in this way. Okay, so from coordinates to this type of vector, very simple. It's just rearranging the coordinates. So for example, A would be -6, 2. B would be 6, 2. C would be 2 minus 6. So y'all may be wondering, why can coordinates suddenly change to vectors 1? Okay, so reason is because these coordinates, right, are actually based on the origin. Okay, so origin, what I'm referring to is the point here from the xy axis, 0, 0. Okay, so all of the points here will be based on this 0, 0. If this 0, 0 moves, let's say this 0, 0 will be moved to here, so all of these points will also change, right? Because all based on this origin point. So this is similar to vectors as well. All of the vectors would be following the origin, right? So for example, the position of Ali's house. Okay, so let's say I plot it in this diagram, and here is point A, this is the x coordinate, this is the y coordinate. Okay, so for vectors, we'll be using origin as the base or as the reference. So to find the vector, we will be always using O to A. Okay, so here to find the vector, we are going 6 units to the left. So here would be -6i, and going up 2 units, which is 2j. So our vector here is -6i plus 2j. And if we change it to the column vector form, it's actually -6, 2, which is similar to the coordinate. Alright, so why can we change coordinates to the column vector format? It's because the coordinates and the vectors all are based on the same point, which is the origin. Okay, so now going back here to find the vectors, what we can do is we minus the column vectors of the points. Right, so for example, if you want to find vector AB, we can use the column vector for the endpoint, which is B, minus with the column vector of point A. Right, so we can do it in this way. Same goes to the vector BC. So the column vector for the endpoint, which is 2 minus 6, minus with the column vector of the starting point, which is 6, 2. Okay, and then we simplify to get the vectors, and then we simplify again to find the vector of AC. And for the second part, we need to find the unit vector of Ali's movement. Okay, so we are going to use back the answer from part 1. Right, so again, unit vector is just using the original vector divided with its magnitude. Okay, so the magnitude x and y here is actually the numbers of the column vector, which is 8 and minus 8. Alright, so here what we can do is we write out the original vector first, 8 and minus 8, and we divide with the magnitude. So I just substitute the 8 inside the x and y here to get this result. Alright, so as you can see in this square root here, right, we have 2 8 squares. Right, so this minus, if we square, it will be positive. So here it would be 8 square plus 8 square. So if I simplify, I will get 2 8 squares. Right? So this 8 square, I can take it out from the square root, because the square and the square root I can cross off. So when I take the 8 square out, it will just be 8. Okay, and then I multiply this number with the two values here to get the final result. And for part B, it says that they are planning to build this petrol station at point E, which has a coordinate of k6, and it says that the points C, B, E are collinear, right? So this means if I join up E, B, and C, the line would be a straight line. Okay. This also means that they are parallel. Okay, so parallel means that for the lines inside this straight line, which is EB and BC, if I split them out, both of them would be parallel to each other because both of the lines are from the same straight line. Okay, they are from the same straight line. That's why they are parallel. Alright, so now we need to find the value of k, which is the x coordinate of point E. Right? So since we know that they are parallel or collinear, we can use this information, okay, or this equation, which is if you want to find one parallel vector, we can use another parallel vector. It's just to multiply a value. Okay, so this symbol is called lambda, L-A-M-B-D-A. Alright, so to find the coordinate, what we can do is we find the two vectors inside this line first. Alright, so one of the vectors we have already found in part A, which is vector BC. So now we just need another vector, but the vector needs to include point E. Okay, because we are finding the coordinate of point E. Alright, so why not we choose vector EB? Okay, so I can put the vector BC here first, and to find the vector of EB will be the same way in part A lah, right? Which is to find the corner vector of the endpoint, which is B, which is 6, 2, minus with the corner vector of point E, which is k6. Right? So it will be something like this. Then I simplify. So now what I can do is compare the values above and compare the values below to form two equations. Alright, so the first equation we have two unknowns, the second equation we have one unknown, so let's simplify this first. Okay, so if I simplify, I can get lambda equals to 2, then I can substitute here, find the value of k, which is 8. Question 7 comes from functions. So here we have a f of x function, and here we have a very important information. So for this part, it actually means if the x I apply to g first, then I apply into f, I still get back the same result, which is x. Okay, which is this one lah. Okay, this one. And for this part, it's the same thing as well. It's just that the functions are reversed. So I put f first, then I put g, but I still get the same result, which is x. Okay, so in summary, this means that if x I apply it to one of the functions first, let's say f or g, I will get a result. But if I use this result, I apply it back to one of the functions here, I will still get back the same result that I have before. So this means that g and f are inverse of each other. Because if I apply these two functions, I will still get back the same result. Okay, so for example, I apply f first, then I apply g, I still get back the same result. So this proves that these two functions are inverse of each other. And for part A, we are finding g of x, so this means I need to inverse this function. So to inverse this function, I would use this washing clothes example. Okay, so this washing clothes example means that I would assume that this function f of x is a dirty shirt. Right? So this shirt is is dirty on the outside and the inside. So to clean this shirt, we need to have two soaps. Okay? But how does these two soaps apply to inversing this function? right? So to inverse function, if you remember, we need to have two assumptions, right? So one is we need to let y equals to f of x, and the other one is x equals to inverse of y. Okay, so to get this one very simple, it's just the f I move to the other side. So if I move, this will become f inverse of y, and on the right side it will be x. So this thing is actually the same as this. Okay, and it comes from here. So going back to the shirt here, the first step to clean this shirt is to apply the first soap and clean the outside of the shirt first, right? So this means that for the function here, we need to apply the first assumption that we have to change f of x to y. Okay, second step, once we clean the outside of the shirt already, and then we do flip the shirt, right? So in the equation here, we need to flip the left side. So means from y, we need to change it or flip it to x. So everything which is x on the left, everything which is y on the right. Okay, so here needs a little bit of rearranging the equation lah. So here we need to make sure that x is on the left. Okay, so once we flip this shirt already, then we clean the inside of the shirt using the second soap. Or this means we use the second second assumption here, which is the x changed to inverse of y. Okay, so once we clean the inside of the shirt already, then we can flip it back. So means here we need to flip all the y's back to x. Okay, change all the y's to x. And this would be our inversed function. Okay, but this cannot be our final line because here it says we are finding g of x. So this f inverse of x, we need to change it to g of x lah. Okay, so this would be our answer. Right, but for this part, I am actually not quite sure is it required or not, because in the answer scheme for this paper it requires, but for the other answer schemes for other states, it does not require. So I'm not sure whether it's required or not required. So this one I think y'all can ask your school teachers to confirm on this. So once y'all know, maybe y'all can comment in the comment section below lah. So the students here watching this video will also know. Okay? And for part B, we need to find the values of x if f of x is equal to g of x. Okay, so here it says values, meaning we have more than one answer lah. Okay, so we need to take note of this. Right, so f of x equals to g of x would be something like this, and here we just cross multiply lah. Okay, and then we simplify, then we can get a quadratic equation. So here we can factorize 7 out first. Okay, and then we can use the factorization way, or meaning using the calculator to find the two values of x. So our values of x would be 3 over 2 and negative 5. Question 8 focuses on probability distributions, and here we have a box that contains these balls, right? So 5 blue ones, 10 green ones, and 15 yellow ones. Okay? So here there's an experiment, which is a ball will be drawn from the box and then will be put back into the box, and this process will repeat 3 times. So according to this experiment here, we need to complete this binomial distribution table below according to the number of green balls drawn. Okay, so this is the focus. We need to focus on the green balls. Okay, so this means that the value of x here, we need to set it as number of green balls drawn. Okay, set our focus to green balls only. The rest we can ignore. Okay, so x here, since it follows this binomial distribution, so here we need to have 2 main parameters, which is the n and the p. So n here is the number of trials of this experiment, which is 3, because this process is repeated 3 times. Okay, and p here is the probability of success, so meaning the probability of getting green balls from the box. So to find the probability, we can use the values here. So number of green balls divided by the total number of balls. So 10 divided by 30, which is 1/3. So now going back to the probability distribution table here, what we need to have is the probabilities according to each possibility of R, or each possibility in this experiment. Okay, so to find the probability, we can use the formula given in the formula sheet, which is this. Okay, so for each value of R, we need to find the probability. Right, so here the values that I'll show you later, the working that I'll show you later would be similar. It's just that the values of R would change. Okay, so for the first part would be 3C and according to the value of R. Second part would be the probability of success, which is 1/3, and the power would be the value of R. And Q is the probability of failure, so 1 minus 1/3, so it's 2/3, and here will be according to the value of R and will minus with N. Okay, so here we can put into a calculator, find the 4 probabilities, and please put these probabilities into the table here. Okay, so according to the table here, we also need to do one more thing, which is to draw a graph. Okay, so let's go to the whiteboard to draw this graph. So to draw the graph, we need to set our x-axis and y-axis first, right? So for x-axis, we are going to label it as R. Okay, so here we will put all the possibilities of R lah, 0, 1, 2, 3, and you will notice that 0 doesn't start from here. Okay, it starts from here because 0 is one of the possibilities, so it needs to start from here. Okay, and for the y-axis would be the probability part, so the labeling I will put this. Okay, P bracket x equals to R, and for the scaling I will use the given scale here, so 2 cm to 2/27 units, so 2 cm is one big box, so one big box is 2/27, and to find the next number I just add 2/27. Okay, so now to plot these probabilities inside the graph, what we need to do is just to draw straight lines according to the possibility. So for example, when R equals to 0, the probability is 8/27, right? So we are going from 8/27 and just draw the straight line. So this would be the same process for the other R's as well. Okay, so the result will be something like this. So for R equals to 1 and R equals to 2, the probability is, the fraction of the probability is different from here, which is 27. So we need to multiply 3 for numerator and denominator to get these two values and plot inside here. Okay, and for R equals to 3, since it's 1/27 only, so we only need to draw half of the box. Okay, for part B, it says that the mass of workers follows a normal distribution with these parameters. Okay, so the x here would be the mass of workers, and it follows these parameters where mean is 65 and the variance is 100. So this is variance, not the standard deviation, because standard deviation you will have a square on top. Okay, but here it does not have a square. Alright, so this is the variance, not the standard deviation. So the next sentence, it says that 84% of the workers have their mass between these two numbers, and we need to find the value of k. Alright, so to solve any kind of normal distribution question, we are going to use the 5S method to help us. So the first S is to write out our probability statement, which we can find using this sentence. So here it says that the probability where the mass is between these two numbers will be 84% or 0.84. Okay, the second S would be search our parameters, which has already done here. Okay, the third S would be standardizing. So standardize would be changing the X to Z using this formula. So x minus mu divide with the sigma. So minus mean divide with the standard deviation. So what we do here is minus the mean divide with the standard deviation. So here is the variance, so we need to square root to find the standard deviation. That's why there's a square root 100 here. Okay, and once we simplify, this would be our result. And for the fourth S is to sketch the normal distribution graph according to the statement here. But if you look at the values here, these two are actually the same. It's just that one is negative and one is positive. So our area that we are going to sketch later would be starting from the center. Okay, because these two are actually the same. It's just one is negative, one is positive. Alright? And here we need to sketch a very large area because we are covering 84% of the graph. Okay, so we can put a negative k over 10 and k over 10 at the sides of the graph, which is something like this. Okay, so again, these two values are actually the same, so we are going to start from the mean or the y-axis here, and we sketch to the left and to the right. So this would be our sketched area. And for the last S, we need to select the values from the probability distribution table that we are going to see later according to the sketched graph here. Right? So the sketched graph, we need to satisfy these two criteria, so it must be one-sided and must be sketched from the right. But as you can see here, we failed both criteria. Okay, so how do we adjust our sketched area here to satisfy these two criteria? So one of the ways is, instead of focusing on the areas that we want, let's focus on the areas that we don't want, which is the two sides here. Okay. But for these two sides, only one side satisfies both criteria, which is this one. The reason is because this area can be sketched from the right side, but this one is sketched from the left, so it fails this criteria. But both areas actually satisfy the first criteria, which is one-sided. But just that this is sketched from the left, so this one failed this criteria. Okay, so according to the green area here, we are going to write out a probability statement. Okay, so here you guys can see this area sketches to the right side, so what we can do is we can write this way: probability where z is greater than k over 10. Greater than because greater than looks like a go to the right side arrow, and this is going to the right, so we are going to put greater than here. Okay, and for the probability part, we can actually calculate. Okay, because this orange part is 0.84, and if you want to find the other two areas, it will be 1 minus this value, right, which is 0.16. But because this graph is symmetric, and these two values, if we don't care about the positive and negative, these two are actually the same. So this means this area and this area is the same. Okay, so this means that this 0.16 I can divide by 2 to find one of the sides area. So this green part will be 0.08. Alright, so now we can use this, and we are going to go to the probability distribution table to find the value of z. So the probability is 0.08, so the first step is to find the first value which is larger than this number. Okay, so 0.08 is this one. Okay, as you can see, the next number is less than this number already. So we are going to use this number, and the next step is to find the differences between these two, which is actually 8. Okay, so we are going to go to this column to find the value of 8 and using this row. Okay, so the value of 8 is here. Right, so once we identify these two numbers already, then we can find the value of z from section A, B, and C. Okay, so for section A is 1.4, section B is 0, section C is 6. So our value of Z is 1.406. Alright, so according to the tables, the Z value is 1.406, so I can compare this value with this value to find the value of K, which is 14.06.